Hi friends, greetings of the day. Today we will see about the pharmaceutical water system and the utilization of water system, how it will be utilized, how it will be monitored, and how it will be treated for the further pharmaceutical use. There are different pharmaceutical waters. You can say that. So water for pharmaceutical use as a purified water, the condition and the source of water we have to dictate the treatment and required of the render to save the human consumption, that is the pharmaceutical water. Typical treatment includes desalinization, softening, removal of specific ions, particle reduction, and antimicrobial treatment. So bulk purified water, it should meet the relevant pharmaceutical specifications for chemical and microbiological purity, and appropriate action and alert limit should be there. It should be protected with recommendation and microbial proliferation with the reverse osmosis, electrodeionization, and vapor compression. Bulk highly purified water, this grade of water must meet same quantity, same quality standard as water for injections, including the limit for endotoxins, but the water treatment process used may be different. Current production methods include, for example, double pass RO coupled with other suitable techniques such as ultrafiltration, deionization. The chosen water purification method or sequence of purification steps must be appropriate to the application in question. Following should be considered when selecting the water treatment method: final water quality specification, quantity of water required by the user, available feed water quality, variation, seasonal variation should be considered, the availability of suitable support facilities for system connection, raw water, electricity, heating, chilled water, compressed air, sewage system, and exhaust air. The sanitization strategy should be fixed, availability of water treatment equipment on the market, and reliability and robustness of the water treatment equipment in operation should be available. The yield or efficiency of the purification system, the ability and adequacy, support and mainly maintain water purification equipments. Whatever the purification systems or the spares or the water system maintenance should be followed rigorously. The specification for water purification equipment, like their storage distribution system, should take into account, like location of the plant room, extreme temperature that the system will encounter, risk of contamination, contamination from leaches, contact materials, the adverse impact of absorptive contact materials, because sometimes whatever the materials you have used in the water system, like PVC or SS, that should be considered, because it is more leachable materials are observed inside the system. So hygienic and sanitary design where required, corrosion resistance, freedom from leakage, a system configuration to avoid proliferation of microbiological organisms, tolerance to cleaning, sanitization agents, thermal and or chemical. Means there are three types of sanitizations: chemical, thermal, and sanitization. System capacity and output requirements, provision for necessary instrument stage sampling points to allow the relevant critical quality parameters of the complete system to be monitored. Typical process employed at user plant or by plant water supply authority includes desalinization, filtration, softening, disinfectation, and sanitization by sodium hypochlorite, chlorine injection. Iron or ferrous removal should be there, precipitation removal should be there, reduction of concentration of specific inorganic as well as organic material. The unit process steps should be provided with appropriate instrumentation to measure parameters such as flow of the water system, pressure, temperature, conductivity, pH, and total organic carbon. Ambient temperature systems such as ion exchange, RO, ultrafiltration are especially susceptible to microbiological contamination, particularly when equipment is static during period of no or low demand of water. It is essential to consider the mechanism for microbiological control and sanitization. Many times it happens, we are not properly taking care of the water system, so we are observing there are failures in the water system. So how to avoid that? Like that, maintenance of minimum flow through the water generation system is recommended at all times. Control of temperature in the system by heat exchanger, a plant room cooling to reduce the risk of microbial growth, guidance value is less than 25 degrees centigrade, provision of ultraviolet disinfection, selection of water treatment component that can be periodically be thermally sanitized, application of chemical sanitization including agents such as ozone, hydrogen peroxide and paracetic acid. Thermal sanitization is performed at more than 65 degrees centigrade. So appropriate sanitary specifications, plastic and stainless steel materials are utilize. So acceptable as per water purified systems requirement. When stainless steel is used, it should be at least 316 in general, 316L, or as a higher grade of stainless steel should be used. Internal surface of the water system smooth, it should avoid roughness, crevices within the water system. Crevices can be source of contamination because possible accumulation of microorganism and formulation of biofilm. Crevices are also frequently sites where corrosion can commence. Internal material finish should have arithmetical average surface roughness of not greater than 0.8 micrometer. So materials, what type of material should be used in the water system? So that material should be fixed, as well as basis on the risk analysis we have to use the materials for the water purification system. Suitable materials that may be considered for sanitary elements of the system includes 316L, that is low carbon, stainless steel, polypropylene, polyvinyl difluoride and perfluoroalkoxy, that is choice of material should take into account to the intended sanitization method. Other materials such as unplasticized polyvinyl chloride UPVC may be used for treatment of equipment designed for less pure water such as ion exchangers and softeners. System that appropriate and operate are maintained at elevated temperature, example greater than 65 degrees centigrade, are generally less susceptible to microbiological contamination than systems that are maintained at low temperatures. When lower temperatures are required due to the water treatment process employed or temperature requirement for water in use, special precautions should be taken to prevent the ingress and proliferation of microbiological contaminant. The growth of microorganism can be inhibited by ultraviolet radiation source in pipework, maintaining the system heated greater than 65 degree centigrade, means up to 80 degree, and sanitizing the system periodically using hot water, guidance temperature greater than 70 degree centigrade. So logically or best is 80 degree centigrade. Sanitizing the system periodically using superheated hot water or clean steam. Routine chemical sanitization using ozone or other suitable chemical agents. When chemical sanitization is used, it is essential to prove that the agent has been removed prior to using the water. Means like as ozone is treated, so ozone should be 100% removed. The ozone can be effectively removed by using UF radiation, ultraviolet radiation. The qualification of water system should be done in three-phase approach. Like three-phase approach should be used to satisfy the objective of providing providing the reliability and robustness of the water system. Phase 1, sample daily or continuously monitor the incoming feed water to verify its quality, and the test period of is 2 weeks. The test period of 2 weeks should be spent monitoring the system intensively for phase 1. During this period, the system should operate continuously without failures or performance deviation. Later on, phase 2, a further test period of 2 weeks should be spent carrying out further intensive monitoring while deploying all the written SOPs. The satisfactory completion of phase 1 means phase 1 which will be conducted for 2 weeks. After that, phase 2 shall be conducted for 2 weeks with all the controls SOP and without any deviation. Phase 3 typically runs for 1 year. The satisfactory completion of phase 2, water can be used for finished product formulation also, manufacturing purposes during this phase. Means in phase 3, we can use the water for manufacturing purposes after completion of successful phase 1 and phase 2, which has the following objectives: to demonstrate the reliable performance over an extended period, to ensure the seasonal variations are evaluated. This may include microbiological quality of water as appropriate. Monitoring data should be subject to trend analysis. Trending should typically be within 2 sigma levels. Suitable alert and action levels, action limit should be established. Maintenance of maintenance of a water system, that is, we have to maintain the water system throughout the life of the water. So how it is required, because if any maintenance or failure in the water system, it leads to deviation as well as the risk for the product. So deficiency, defined frequency of the water system elements should be there. Calibration program, SOP for specific tasks. Each and every task should be conducted through the SOP. Control with approved spares. All spares should be additionally approved and available with the help of engineering team. If any spares is breakdown, you can utilize the spares whatever available with you. Issue a clear maintenance plan. Review and approve the water system. During review and record, if any problems or deviation observed, we have to record through the QMS procedure. The review team should comprise representative from quality assurance, microbiology, production, operation, maintenance, engineering. The review should consider following changes, like that changes made since last review: system performance, how system perform for whole year, reliability of the system, quality trends, microbiological trends, chemical trends, investigations. If any failure is there, we have to identify. Any OS, OT deviations or is available, we have to investigate thoroughly and we have to act accordingly with respect to the kappa. So new system or system that display instability or unreliability, the following should also be reviewed. Need for investigation is required to capture any failures in the water system. Corrective actions and preventive action shall be taken in case of any deviations or OS is observed. Steps for water purification process. General steps for purification water of drinking. It includes aeration, that is, the raw water is first collected in last storage tank, and the water is aerated by bubbling compressed air through perforated pipes. As well as aeration removes the bad odor and CO2, it also removes the metal such as iron, manganese by precipitating them in their respective hydroxides. Storage or setting. How we have to store the water, that is aerated water then placed to in settling tank and stored for 10 to 15 days. During storage, 90% of the suspended solids settle down within 24 hours and the water becomes clear. This settling method is utilized mainly when the water is collected from the you can say that lake or some rivers. So that time water stagnancy is there, so settling of mud particles should be essential. So certain heavier toxic elements or chemicals settle down during the storage. Similarly, pathogenic bacteria gradually die and bacterial count decreases by 90% in the first 5 to 7 days storage. During storage, organic matter present in the water is oxidized by microorganisms. Similarly, NH3 present in oxidized into nitrate by microorganism during the storage. After that, storage or settling the particle, sometimes coagulation is required. It is not every time required. It is when the water is very muddy, that time we have to use that. Water from storage tank then placed into the coagulation tank and some precipitating agents such as alums, limes added in the water and mix it. This precipitating agent from precipitate aluminum oxide hydroxide, and when dissolved in water, suspended solids absorb on the surface of precipitate, so Gradually, mass of precipitate becomes heavier and finally settle down. This technique is used to remove the very light suspended solids that do not settle by themselves during the storage. Furthermore, it is negatively charged colloidal impurities are present and it should be neutralized. Filtration. Then filtration technique sometimes we have to utilize partially clarified water then pass through the sand filter or sand gravity filter, which removes 98 to 99% of the microorganism and other impurities with the help of sand filters. Sand gravity filter, sand filter rectangular tank in which filter bed is made up to three layers. Top layer, fine layer, that is 1 meter thick. Middle layer is zero point 0.3 to zero point 0.5 meter thick, less layer of the coarse sand, and bottom layer zero point 0.3 to zero point 0.5 meter thick layer of the gravels. So these are the three layers which is utilized in the filtration technique. There is a collection water at the bottom of filter and collect filtered water during the filtration. Filter bed soon gets covered with slimy layer called vital layers. Vital layer consists of threads like algae, diatoms and bacteria. During filtration of the microorganism present in vital layer oxidize organic and other matter present in water. For example, if NH3 is present, it is oxidized into nitrate. Vital layer also helps filtration of microbial cells. Later on, water contains unpleasant odor. Sometimes activated carbon may be placed in the filter bed. Means after sand filter, there is a activated carbon which can use for the filter bed that removes the bad odors. Disinfection of the water. Filtered water is finally purified by using disinfectant, that is the chlorination. It is also called as a chemical treatment. Disinfectant kills pathogenic as well as other microorganism in the water. Also, disinfection water is pumped into the overhead tank for subsequent domestic distributions. Purified water system flow, it is available, and if anybody wants they can mail me. I can say share you the complete flow of the flow diagram as well as this literature also. Purified water system flow. First, water is treated with the raw water when comes from borewell or the river. It is treated through the multigrade at sand filters. Activated carbon filters, exchanger unit, that is we have to use, that is membrane filters are there. Then it pass through the RO membrane. Then it is treated for the UV disinfection. So after UV, it is electro deionization has been carried out to remove of the all the elements, chemical elements. After that, generation water passes to the generation system, and through generation system, water is stored for the storage or in the storage tank for the users usage. And after this storage tank, there is a distribution or the user points where the user can collect the purified water in their areas. Sanitization, if we want to see sanitization, it mostly perform with the chemicals, that is like chlorine, thermal sanitization with the hot water, and sanitization with ozonation. Sometimes ozonation is also used for the sanitization. There are different monographs given: EP monograph, BP monograph, USP monographs. Like as test parameters, we have to see appearance, total organic carbon, water conductivity, nitrates, acidity or alkalinity, chlorides, sulfates, ammonium, heavy metals, residue on evaporation, oxidizable substance, calcium and magnesium, microbial contamination, that is for TAMC, microbial limits, and microbiological monitoring. So all these parameters we can monitor for the water treatment plant. As well as the following are the numerical values which can be controlled through the water system, or that are commonly used for the interpretation of the procedures. Okay, so pH should be 5 to 7, in the range of 5 to 7. Chlorides 0.5, sulfate milligram per I 1.0, ammonia 0.0, calcium 1.0, carbon dioxide 5.0, oxidizable substance pass the USP permanganate test. Bacteria, We can say that bacteria purified water CFU per ml 100, WFI limit is CFU per 100 ml 10. Sterile purified water pass the USP sterility test as per the monograph 71, and TOC shall be 500 ppb. Then carbon conductivity 1.3 ts per centimeter square and 1.1 ts per centimeter at the rate 20 degree, and endotoxin for WFI, that is 0.25. So this is all referred from the USP monograph 1231. So sanitization is mostly carried out 80 degree centigrade, and it should be continuously recirculating water inside the system. So proper the sterilization or sanitization will be conducted. Many times chemical treatment is also required, like typical methods oxidizing agents such as hydrogenated compound, hydrogen peroxide, ozone, peracetic acid combination, hydrogenated compounds which are used for the sanitization system. Hydrogen peroxide and ozone rapidly degrade to water, and oxygen peracetic acid degradations occurred to acetic acid in the presence of UV light. In fact, ozone is a degradation to oxygen using 254 nanometer UV lights at use point allow it to be most effectively to use on the continuous basis to provide the continuously sanitizing condition. So UV light should be wavelength should be 254 nanometers. Okay, and it can be 254 nm or nanometer can be used to continuously sanitize the water circulating into the water system. Such percentage or high percentage, but not limited to 100% microorganism that flow through the device but cannot be used directly, so all the microbial growth will be reduced. However, when coupled of the conventional thermal as well as the chemical sanitizations technologies are located immediately, so upstream of the microbiologically relative filters, it is most effective and can providing the relevant between system sanitization. So this is all about the water system we learned here. And if you want any question, or if you have any doubts or literature with respect to the water system, you can mail me kiranbambalkar9 @gmail.com, and I will provide you the all content here. Thank you.